Hey everybody, Shawn here from the Automation Blog and School, and this week on the Automation Podcast I meet up with Steve Mustard and Pascal Girerd to learn all about soft PLCs.
Steve and Pascal, thank you so much for coming on the Automation Podcast. Now, before we jump into the topic we're going to discuss today, could you tell our audience a little bit about yourselves?
Yes, thank you, Shawn, for the opportunity to talk to you and your audience again today. I'm Steve Mustard. I'm an industrial automation consultant. I've been working in engineering for 33 years and worked in a range of different sectors. One of the things that I've been involved in for a long time is soft PLC implementations, and that's what I'm hoping we can talk to you about today. I'm an active volunteer in the automation industry, and I am the immediate past president of the International Society of Automation. And with me today is Pascal. Pascal, introduce yourself.
Yes, thank you, Shawn, for this opportunity to talk about soft PLCs. I am Pascal Girerd, manager for Straton's worldwide sales. After 25 years of development for industrial softwares in many kind of environments, followed by 10 years in sales, I am here at Straton Automation since 2019, enjoying to find the best solution with our customers worldwide in the industries of automation, embedded, energy, and utilities.
Excellent. Well, I'm excited that, I haven't talked about soft PLCs in a while, so I'm excited to have you guys bring us up to speed and share your thoughts. I know you've done papers, you've done seminars and whatnot. So, with that said, if you guys, and I also want to welcome Steve back. I forgot to do this at the beginning. Welcome Steve back onto the podcast. This is his third time on the show. And Pascal, welcome. This is your first time. I appreciate you both coming on to talk soft PLCs. So, with that, let me turn it back over to you guys and we'll jump right in.
Thanks, Shawn. And again, I appreciate the opportunity to talk to you and the audience. You have a great audience, and you produce a lot of very informative podcasts about issues and solutions in the automation profession. And it's a great opportunity to talk about soft PLCs. As you mentioned, it's something that has been around for a long time. And what we have noticed is that there are some popular myths and misconceptions about what soft PLCs are and aren't. And we're hoping to dispel some of those today. So I wanted to start with just to make sure people are aware of IEC 61131-3. So this is an international standard. The international standard is actually 61131, and there are 10 parts to it, and -3 is part 3. And part 3 specifically talks about the programming languages that are used for programmable electronic devices. So the soft PLC standard, or the 61131 standard, was developed in the early 90s, and it's been around ever since, actively used to define what a PLC or a programmable controller is. In part 3 talks about the 5 languages that are defined in the standard. So they're sequential function chart, function block diagram, ladder diagram, structured text, and instruction list. The last one, instruction list, is deprecated now because it's not particularly useful, but it's still defined in the standard if needed. As well as the languages, the standard also defines the variables and types that are needed, and also the functions that are going to be available for users. Functions, for instance, to do arithmetic and logic capabilities. So what's nice about that standard is that it is a standard that everyone can follow, and therefore if you write a program in 61131 compliant language, then you can easily translate it from platform to platform. Now, the soft PLC itself is something that is synonymous with that standard. But as I mentioned at the beginning, what we have observed is that today, if you mention soft PLC, there's a number of myths or misconceptions about what they are and what they aren't, and what they're capable of doing and not capable of doing. And I've summarized those things into 3 main areas. So the first one that most people think is, when we talk about soft PLCs, this is not suitable for a traditional conventional PLC type operation because it's non-deterministic. And the reason for that is because in the early days of soft PLCs, this software was running on conventional industrial PC hardware, usually running a Microsoft operating system, say Windows NT or Windows CE. And those operating systems are not designed to be deterministic. And so if you're running something on a non-deterministic operating system, it's going to be non-deterministic. The second thing that comes up is very similar issue, is that the soft PLC solution is often considered to be not suitable for use in the rugged environments that we would see conventional PLCs. And again, that's probably for similar reasons. The most of the hardware that was used in the early days was off-the-shelf PC cards that were not designed to have the environmental or vibration or shock standards that would be required for a device that was used in an industrial environment. And then the third thing that comes up is security. So we're talking about things that, again, typically run on Windows operating systems. And we know that Windows operating systems have been the target for exploits for many years now because they're so commonly used. And so if you're using a soft PLC running on a Windows type operating system, then you're inevitably going to be vulnerable to security issues. And that's especially true in the industrial environment, where the options to upgrade that platform and incorporate the latest security patches is very limited or very challenging.
I want to jump in here. Back in '98, I had to go for my Rockwell certification again. And part of that included soft PLCs. And really, you make some great points here because, people could argue that Windows NT was, I'm Windows NT certified 4.0, but people could argue, well, that was a great operating system. But think about this, right? Industrial PCs have nowhere near the mean time between failure numbers that conventional PLC hardware has. It's not even close. I mean, they pale in comparison. And you know what? We didn't have a lot of people on the internet in '98. I was still running a BBS because people didn't, their companies weren't paying for internet access. So that wasn't such a big problem then, but it is a huge concern today. And there's just this inability when you're using a Windows PC, even if it's industrial, to guarantee the operating system will be the same, that all the software will be installed the same, that all the hardware will be the same. That never happens. As every major vendor sells industrial PCs, and they can tell you, they try to hold it for 5 years or 6 years. But you know what? You can still buy PLCs that came out today. You can still buy PLCs, hardware PLCs that came out decades ago. So I definitely see some of these myths coming from those early experiences. So I just wanted to throw that. That's kind of my own experience.
Yeah, no, I think that's what we've seen is a lot of the people who have those misconceptions. It's because they looked at it early on and it wasn't ready then. It wasn't really suitable then, and so they haven't looked at it again since, perhaps. And so what we're trying to do is we're on a mission to try and raise awareness of the fact that things have changed since then, and maybe people can take a look again and see if they may be suitable now. So with that in mind, I've got some examples here, and I hope that when people look at these examples, they think that actually this soft PLC stuff that we just talked about is actually really are myths, because the devices that you can see on the screen here, all of these run a soft PLC at the heart of their operation. So we have conventional or semi-conventional RTUs and PLC devices that you might use in energy sector, for instance. We've got embedded devices that are deployed in transportation, things like buses and trains. We've got the kind of conventional rack-based PLCs that you might see in a treatment plant or an oil and gas facility, and so on. And so the fact that these devices actually all run soft PLCs is quite interesting, because people are using these and they probably call these conventional PLCs, but they don't really realize that behind the scenes is a soft PLC. And one of the other things about these devices, hopefully people can see, is the scale of them, from very small embedded devices to quite large, rack-based PLCs that you might consider equivalent to things like control logics and other things. So it's very scalable, and it's also very adaptable. And the other thing about the 61131 standard, as I mentioned right at the beginning, is if you imagine that you write a program that's compliant with the standard and it runs on one of these devices, then you can actually take the same code and you can run it on one of these other devices. And the standard requires that those things can support the same functionality. So that, I think, is a huge benefit, because we're talking about making it much easier to port code across different platforms. And also, one of the things you touched on there, Shawn, about the maintainability and the obsolescence nature of these types of devices. Maybe some hardware does become obsolescent, but actually you can readily take your code and port it to another hardware device in the future.
So instead of using off-the-shelf PC components, you have people, these hardware platforms, they're designing their own circuits, their own circuit boards, they're manufacturing them, they're packaging them, they're making sure they have the same mean time between failure that an engineer would expect for an industrial environment. This eliminates, hey, it's just a conformally coated PC with higher temperature ranges. These are actually, to me, it looks like these are actually industrial, devices designed for industrial implementation. And for those who are listening, I mean, what we're seeing on the screen here is everything that looks like, from something that looks like a micro PLC to something that looks like like the computer module that's in your car, to something that looks like a DIN rail mount style, like a network card, and a rack-based PLC. So just to kind of give you some visuals, if you're only listening, you're not watching.
Yep, that's a great summary, Shawn. Yeah, and that's exactly the message we want to get across, is the scale and the functionality capabilities are really dependent only on what the manufacturer wants to make, so they can choose the hardware specification they need and then port the soft PLC to it. So at this point, I'd like to hand over to Pascal. I talked about some of the myths. I've hinted at some of the fact that those really are myths, but I'd like Pascal to maybe dig in a little more and tell us a bit more about why those really are myths. Pascal?
Yes, thank you, Steve. Okay, I will give you a brief presentation of Straton Automation. It's made by a movie, so it's very quick. Then you will have a very short landscape by this way.
So at this point, Pascal played an impressive but completely silent video presentation, which I'll include at the end of the video edition of the podcast. But for now, I'm just going to include a couple of the main slides here. And then, because I don't want to leave the audio audience in, dead silence for a minute, I'm going to jump us right back into the conversation.
That was quick and enough to show you what is Straton. You see, automation is everywhere from this short movie. That's why we cover nearly all industries. In other words, all sectors that require control, regulation, automated tasks. We have references ranging from mobile automation, small machines, to power grid management. In embedded, like in mobile automation, in any machine used for production, like weighing system or motion, or to manage a specific process in a machine, like a cemetery or a diagnostic machine in the health science. It's also building management with a pump or a cooling system. You see here that embedded can also mean utilities and energy, as in the case of metering or water management system. We are very experienced in this field and have already realized many interesting projects. We are very strong also in energy and utilities, which means electricity, water, and gas management. We address manufacturers of remote terminal units or equipment, like a disconnecting device protection relay, in electricity for its production, its transport for the substation, automation smart grid, for instance, and its distribution. It's in water distribution for clean or wastewater, and for irrigation with the NP3, in rail at substation and TCMS, train control and management system, and also for telecommunication for managing energy, and even in cruising vessels, where we have to manage in a secured way many equipment, even energy produced aboard. You see, in fact, automation is very everywhere, I should say. And now I can give you a look on why we should use a soft PLC. As I said before, automation is everywhere. You see here trains, buildings, trucks, tanks, pumps, wind turbines, factories, energy at production, transport, and distribution everywhere. And above all, you want to have control, regulation, and automatic tasks, sometimes in a rough and teeny environment, and more communicating at the age of IT/OT. So let's go and see why a soft PLC would be a good solution now. It's time to market. I must bring my device to market in a short time. I have obsolescence issues. My customer needs solutions soon, and I must be agile to support my customer needs. Imagine you, OEM, get a request from a customer for a new software feature, and only software. For example, you need the latest version of a communication protocol, but you have no time to develop it. Do you think it could be possible with any standard PLC, with a supply chain issues, for instance, whereas you have already the electronics? So that means I want to design my hardware solution and develop the application at the same time with a Raspberry, for instance. It is possible with a soft PLC. And I need the integration of a soft PLC or a new protocol to be quick and easy. As my application is written in PLC Open Standard, porting will not be difficult. It is all time to market. It's also flexibility. I want my application to run in the future on a different kind of environment, have different protocols. Flexibility is when I can make with the same application a standalone balance and a big weighing system scaling trucks. And with a soft PLC, the same application can be ported to different hardware and operating system combination, different kind of IOs or protocols. This means that I will be able to potentially develop and maintain a common application, or at least a library of common functions that can run in different environments if needed. This will allow my customer, me as an OEM, to choose my specific combination of hardware and software, saving money on I/O and interfaces. It's also openness. I want an open solution because I want to adapt the application to customer needs. My customer will want to adapt also themselves, the application, thanks to IEC 61131. And for instance, I have to couple my application with an HMI, motion, or gateway feature, any kind of application that can run in parallel in the same hardware as my soft PLC. And also, for instance, I must include my proprietary stack, or I want to use a new disruptive regulation model. But including is not opening. I want also to protect my knowledge, my IP, secured into the PLC, encapsulating my proprietary logic. This is openness. Then I can mix my features to a soft PLC features, and then this brings my device at the convergence of IT and OT, operation, intelligence, and communication. We have also to follow the standards. Following standards is not only a trigger for my market, following standardization with IEC 61131, but also for communication protocols. Simplify the search for resources, help to reduce ongoing maintenance cost, allow greater consistency. Energy market other products with Straton have been successfully certified, like IEC 850 and so on. And even if a user changes soft PLC solution, the use of this standard compliant application code can greatly reduce the cost of migration. This also applies to communication protocols such as CAN and now CAN-FD or MQTT, which are often integrated into soft PLC solution. I want a soft PLC solution that keeps me up to date with changes from this standard. And this benefit can be passed on to my customers. Thus, I can focus on my business. Is it clear for all? I was talking about certification because we are very experienced also in certification. So we do this job for you. It's also financials. Costs are very important factors, of course. I need a cost-effective solution. Exactly matching with the features I want, not more. I want to master the cost all along the life cycle of my project, of my product, like with using ARM processors, not high speed or with a lot of memory, but enough for my application. I make especially the hardware and platform I want with exactly the IOs and field buses I need and not more. It is the best adjustment, far from an off-the-shelf solution. And if I want to make thousands, $1 is very important.
You can definitely see it's kind of like the Android phones, right? So some people want the really, like my son, he wants the really fancy one that splits open and has dual screens and is very expensive. I, on the other hand, I got one that was under $300, and it does what I needed to do. And I can definitely see in different applications, in a lot of applications, people are going to want something that goes on a DIN rail, right? And if it's a simple product, maybe they'd go with an ARM-based processor. But if you're doing something that's controlling a vehicle, then one of those automotive styles, the totally, encapsulated unit, with shielding and whatnot, may be more attractive. Or maybe you have a lot of different IO and you need something that's very flexible and modular. So I can definitely see this it's not just, I think it's financials and flexibility,
Yeah.
because you can develop on one platform, and then we have all, like we saw in that earlier slide, we have all those different platforms where you can send the same program to, the same code to. So I just wanted to jump in there and say that because that came to mind.
Yes, it's right. It's right. And the example of the weighing system was quite interesting because, in fact, the control of the weighing is the same, whatever the power, I should say. But you may use a very small embedded platform for 16 IOs weighing system, whereas if you have a system scaling trucks connected to many interfaces in the factory. It could be a different kind of platform, but in fact, it's the same environment for development. Yeah. And for the OEM, it's good also because he has the same platform on different for development, but different kind of hardware that he can propose. And if I go fast in the integration, it's also money win. So it's financials. I know that if I need more performance or complexity with a second kind of device, I can do with Soft PLC. Today, it's very important is security. Because I'm connected to the outside, we have many threats today. I need the best secured solution. And all along my product life cycle, I want to master. And if I have the sources, I can master it better. I can check everywhere in my sources. I have no black boxes. And I can have my partner giving me secured communication protocols, like with authentication and encryption, always up to date. Thus, again, I can focus on my business. And for others, security is also security for my product lifecycle, because I want to be independent from the obsolescence of components or operating system. And it's true, moreover, today with supply chain issues. And security for my intellectual property, because I want to keep using my code encrypted. It's also important, this kind of security. Seventh point, performance. Because I have to need, for instance, PID loops with an efficiency, determinism, and so on. That may bring me to use real-time operating system with real-time option like Linux plus real-time extension, for instance, or I need to acquire quickly different kind of IOs, or I have very small platform and I have to manage with that. It's a cost point. Today, multi-core CPU makes them capable of multitasking in a very powerful manner. But it's also performance to bring control, regulation, communication in a very small CPU. And we can manage to have, in mobile automation, to have only 128 kilobytes of RAM. Okay, we just have, for instance, scan and Modbus, but it's enough. And it's a very low cost objective. And last point, for us, it's product differentiation. It's very important because every customer is a four-leaf clover. Every customer has different needs. You have seen many kind of industries, many kind of needs. And I must do it, make it unique. Oh, sorry. And many soft PLC solutions can offer functionality over and above the IEC 61131 standard. I want to keep the standard part, but also the open one thanks to that. I've said previously, including an HMI, and keep my application running in same time, or using specific features like a revolutionary regulation model, thanks to Apache, for instance, or get the redundancy, or bring distributed operation capabilities, or get safety in the future with the same development platform. So if I want CAN bus and MQTT on the same device, or a specific field bus, it is easy with a soft PLC. That was the 8 points, but we can consider the criteria to check for a soft PLC. Of course, depending on your position in the project as a developer, product manager, at marketing or sales, you may have different priorities, but there will be at least one or two very important for you. What do you think, Shawn?
Well, I keep coming back to supply chain. We've seen the automobile companies build plants that build the same exact model car on multiple continents, which I think is so brilliant, right? So they can, whether it's BMW or any of these large, Toyota, Honda, they have plants in North America, they have plants in Europe, they have plants in Asia, and I think that's so great. But we don't see that with like PLC manufacturers. Typically, they'll either make all the PLCs in Germany or all the PLCs in Asia or all the PLCs in North America. And so when a problem hits that area of the world, there's no backup plan. You just can't get your PLC. And I think a lot of people have seen this with PLC manufacturers, big and small. I've heard from customers and vendors alike saying, "Oh, we can't get that particular model for 3 months because we have a problem in that place in the world, etc." So with this approach, because there are so many different vendors, and hopefully all these different vendors don't have all the plants in the same city, right? Then that really reduces your concern about supply chain, because you will probably have vendors that support this platform in Europe, in North America, in Asia, and other places. So that just came back to me as you were saying that. I'm like, that's by being able to target different hardware, you kind of break free. I mean, again, I am an advocate for making the same products on different continents. That's, I think, the most, like the car companies do. But until we get there in automation, this is one way you can get around that. You can develop independent of your hardware.
Yeah, it's right. Yes, thank you, Shawn. So my part for why a soft PLC is at the end, and I will leave the voice again to Steve for a final thought.
Thank you, Pascal. Thank you for covering all of the points in more detail that I talked about dispelling the myths about soft PLCs. So, Shawn, thank you again for the opportunity to talk to you and your audience again today. We tried to talk about some of the misconceptions and myths about soft PLCs. They've been around for such a long time, and I think in many cases people looked at them early on and thought they were not suitable for various reasons. But hopefully we can see today that it's changed dramatically, and soft PLCs are routinely used in industrial controllers of all shapes and sizes. And as Pascal talked about, there's many benefits to using a soft PLC at the core of your PLC or RTU type functionality. So I hope that this discussion helps people maybe reconsider and take another look at this technology and see if maybe they can use it for some of their projects and applications.
Thank you. I think we need to. There's one question I think is in everybody's mind, right? Is, well, what can we actually buy from Straton? So we've kind of gone through and talked about the advantages of soft PLCs and how they're different from what I was experiencing in the 90s, right?
Mhm.
So now that we've talked about that, and we've talked, if somebody wanted to consider Straton, what would they be looking at? What is offered by Straton? What what like do what are the products? What are the deliverables?
Well, let me start, and maybe Pascal, you can elaborate.
Well, thank you.
Soft PLC technology that we've talked about today, Straton provides what we call a virtual machine toolkit. And that toolkit is essentially a set of source code for the soft PLC component. And the idea is that suppliers will take that source code and they'll build a runtime that will operate on their hardware. As we said earlier, they choose their hardware appropriate to the particular needs, the particular cost requirements, the particular environmental requirements, and then they customize the runtime source code and build it to run on that hardware. So that's the core of what Straton Automation provides. And then in addition, there's obviously a whole suite of tools and stacks for protocols and other functionality that can go around the soft PLC. But that's the concept. Pascal, do you want to elaborate on that?
No, it's well summarized. I should say it's bringing the soft PLC feature, be able to program in IC 61131, which is a language existing, should say, since 40 years. And it's also bringing a lot of communication features with security, of course. So I think this combination today is at the core of IT and OT. We need intelligence. We need communication in a secured way. So, and you give openness with a soft PLC. You give openness to modify the part you want to be modified. Of course, it's your decision to show or to not show some things. And also you can have it in a secured way, in a safety way with a seal, of course, seal runtime. It's the same kind of products using the same development environment but with a safety runtime, I should say.
I really want to thank you, Pascal, for taking the time out of your busy schedule to come on the show. And again, Steve, and I mean, you guys make me look smart because you guys are educating me. So thanks to you and all the guests that come on the show. And with that, I just want to wish you guys a great day and thanks again for coming on.
Yeah,
Thank
you
you
very much. Thank you.
Well, I hope you enjoyed that episode. I want to thank Steve and Pascal for coming on the show and talking to us about soft PLCs. With that said, if you enjoyed this episode, please remember to give us a like and a sub. And if you're listening to the audio-only edition, please consider giving us a 5-star review so we can find more vendors to come on the show and grow the audience. And I want to thank all of you who have. I was checking out one of the platforms the other day and I saw several 5-star reviews. So thank you so much if you're one of those people who did that. Now, with that said, you will always find my very affordable automation training courses at theautomationschool.com, and you can join my community over at automation.locals.com. And with that, I want to wish you all a very safe, happy, and healthy week. And until next time, peace.